In this video, we're going to work on writing algebraic expressions. So first of all, expressions do not contain an equal sign. An expression is just a mathematical phrase that contains numbers, operations, and variables. Let's take a look and compare numerical expressions and algebraic expressions. So first of all, a numerical expression contains only numbers and operation, but not variables. So, for example, 4 plus 5 is a numerical expression. And remember, expressions do not have equal signs. So, I have numbers and operations. An algebraic expression contains only numbers, operations, and variables. So again, an expression does not include an equal sign. So if I have 4 plus m, here's my number, here's my operation, and here is my variable. Let's take a look at an expression here. So every expression is made up of terms. A term is a known number, a variable, or the product of a number and variables. So in our expression here, we have two terms, and those two terms are 5x and 3. A variable is a letter that stands for an unknown number. So the part of the expression that changes is our variable. And in this case, our variable is the x. So the x in our expression is going to change depending on the numbers that we use. A term that is a known number without variables is called a constant. So a constant is going to stay the same. It does not change. And in this case, the constant is 3. A number used to multiply a variable, that number is called the coefficient. And the coefficient tells us how many groups of the variable that we have. In this case, 5 is our coefficient. It is saying that we have 5 groups of whatever x happens to be. And operations mean things like add, subtract, multiply, divide, etc. In this case, we are subtracting, so our operation is a subtraction sign. So let's put these parts of our expressions to work. So in our statement here, it says Mary is 3 inches less than the height of her little brother. So less than is going to be subtraction, and it says that she's 3 inches less. So each time I'm going to be subtracting 3 from whatever the height of her little brother is. So in this case, her little brother is 28 inches tall. And Mary is, again, 3 inches less than the height of her little brother. So we're going to subtract 3. How tall is Mary if her little brother is 32 inches tall? Well, her little brother is 32 inches tall. And again, Mary is 3 inches less than. So we're going to, again, subtract 3. And if you notice, we're not saying 28 minus 3 equals or 32 minus 3 equals, because an expression is just a statement, a mathematical statement representing the information that we have here. How tall is Mary if her little brother is 65 inches tall? Well, little brother is 65 inches tall. And again, we're going to subtract 3. So now let's look at our questions down here. It says, in the above situation, what term is constant? Well, again, I know from before that constant means staying the same. So when I look at my expressions, what is staying the same in all my expressions? Well, this 3 is. So the number 3 is staying constant in there. And what does that 3 represent? that is Mary's, oops, height is 3 inches less than her brother's. So that's what that 3 represented. What term varies? Well, when I look back at my expression here, this number is changing, and that's what varies means, is it's changing throughout each expression. And what does that mean? That is her brother's height. So now it says to write an algebraic expression to represent Mary's height for any height her little brother is. So again, it says for any height. That means we need to come up with a variable. Well, varies is what a variable is. So that's what's her brother's height is going to be what our variable is going to equal here. So we need to say that. So B equals her brother's height. And again, you could use any letter here. I use B because brother starts with B. So I know B is her brother's height. And what's happening? Well, Mary is always 3 inches less, and that's our constant here. So we're going to subtract 3 from whatever her brother's height would be. So our algebraic expression to represent Mary's height for any height her little brother is would be this B minus 3. Let's take a look here at another situation. Tracy has 5 cans of vegetable juice in her refrigerator. Okay, so we have 5 cans of vegetable juice. If all the cans each have 6 ounces of juice in them, what is the total ounces of juice Tracy has? Well, if I have 5 cans and each of them have 6 ounces of juice in them, I want 5 groups of 6. And groups of is represented by multiplication. So I'm going to take 5 times 6 to get my total ounces. But again, it's not equal because it's an expression. In this case, I have 10 ounces. So we're going to take 5 groups of 10. And in the last one, we have 7.5 ounces. So we have 5 groups of 7.5. So let's go down here to our questions again. What term is constant? So again, constant means the same. So I go up here and it looks like the 5 is what stays the same all the time. So the 5 cans of vegetable juice is what stays constant. That's she always has 5 cans. What changes or what varies? Well, when we look here at our problem, this is what changes or varies. And what is that? What is that? That's how many ounces of juice in each can. So when I write my statement here, what term varies? Amount of juice in each can. Okay? So now I need to come up with a variable. So I'm going to use J for the amount of juice in each can. And again, I get that information from right here. And what is happening with that? Well, I'm having 5 cans and I'm multiplying it by the amount of juice in each can. So my statement, or excuse me, my expression then would end up to be 5 times the amount of juice in each can. But the issue here again is this x. The x could stand for a variable. So when I write multiplication, I'm just going to put my coefficient and my variable. So that means 5 groups of J, or 5 times the amount of juice in each can, just like my statements or my expressions said up here. So let's take a look at this statement. 8 more than a number. Well, I have 8 more than is addition, a number. Well, it could be any number. So this is my variable part. So my variable here, I'm just going to use n because number starts with n. So my expression to represent this would be 8 plus n. The difference between a number and 5, well, when we talk about difference between, that is subtraction. A number, well, I don't know what that number is, so it's a variable. And again, I'm going to use n for that, and 5. So I'm going to put this in my expression. So n minus 5. 9 divided by c. Well, we've got 9 and divided by, and then our variable c. So I can either write it as 9 divided by c, or I could even write it as a fraction, 9 over c. Twice a number n. Well, twice stands for 2. And then here's my number. Well, when I take twice a number, I'm usually multiplying. But again, my x causes problems because I don't know if it's a variable or multiplication. So this would be 2n. K less 7. Well, I know this is k. Less is subtraction. And then 7 is 7. So I would have k minus 7. The sum of g and 11. Well, sum means addition. Again, g for my variable, and then I have 11. So I would have g plus 11. The quotient of x and 6. Well, quotient means division. And then here I have x, and here I have 6. So I would write it as x divided by 6, or x over 6. The product of 9 and n. Well, product is multiplication. 9 is 9, and my variable is n. So I would have 9 multiplied by n. But again, I have that multiplication sign here. So I would have it 9n.